Let us see what are cyclic or closed chain or ring chain compounds. That means whatever the carbon compounds are formed, they will be in the chain structure. Let me give you the definition. The compounds, they contain 3 or more carbon atoms in their molecules. So these are the compounds which are going to have 3 or more carbon atoms in their molecules. So they have properties similar to the open chain hydrocarbons. So they have the properties which are similar to the open chain hydrocarbons. Only thing, they are going to have a structural difference. So these are called as carboxylic compounds. Now let us see this cyclic chain. CH2, CH2, CH2. This is called as cyclopropane. Propane means what? 3 carbon atoms are there. They are linked up with 6 hydrogen atoms. So they are like a cycle. It is a closed chain. It is a closed chain. So as I have said, the compounds contain 3 or more carbon atoms in their molecules. How many atoms of carbon are there? 1, 2, 3. They are linked up like a chain. CH2, CH2, CH2. This is cyclopropane. One more example is this. Here I have taken 5 carbon atoms. 1, 2, 3, 4, 5. Cyclopentane. C5H10. 5 carbon atoms and 10 hydrogen atoms. How many hydrogen atoms are there? 2, 4, 6, 8, 10. So CH2 molecules, they are linked up like single bonds and they made up a cyclic structure. This you call it as cyclopentane, and the structure you are going to represent like a pentane. Pentagon, you have learnt in 3rd and 4th classes, no, the shapes, geometrical shapes. So like a pentagon. Now one more is there. This is cyclohexane. That means hexa means what? 6. 1, 2, 3, 4, 5, 6. 6 carbon atoms. They are linked up with 10 hydrogen atoms. 10 hydrogen atoms. Here 2 hydrogen atoms, 2 hydrogen, 2 hydrogen atoms, 2 hydrogen atoms. But here carbon, hydrogen only 1. Here only 1. 1 hydrogen atom, 1 hydrogen atom. In between you have a double bond. So this is a different structure. Cyclohexane. It is a cyclic hexagon structure. C6H10. Listen, everywhere you are not having 2 hydrogen atoms. Here you are having 2 hydrogen atoms. 2 here, 2 here, 2 here. But here you are having only 1 hydrogen atom. So the bond between these two is double bond. See, I have drawn the cyclohexane structure like this. Here everywhere you are having single bond, single bond, single bond. But here double line means double bond. One more example is benzene structure. Actually the benzene formula is C6H6. That means 6 atoms of carbon and 6 atoms of hydrogen. This is a very, very important structure. Here carbon is linked up with hydrogen, single bond. CH, 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 CH. Everywhere single carbon atoms are linked up with single hydrogen atoms. But what you observe is you will be having single bond alternatively. 1, 2, 3 alternatively. As well as double bond alternatively. 1 double bond, 1 double bond, 1 double bond. So you are having double bonds alternatively and single bonds also alternatively. This is the structure. Now I have drawn, it is like a hexagon only. See here, this is a double bond, this is a double bond, this is a double bond. This is single bond, single bond, single bond. So this is the structure of benzene. Now I have given the note. Benzene ring has 6 carbon atoms having carbon-carbon single bond and carbon-carbon double bonds in alternative positions. So what do you observe in the alternative positions only? No. So after this double bond, again you are finding it here, again you are finding it here. Also single bond also in the alternative positions. Okay, this is about benzene. Next important note is that most of these compounds, whatever compounds I have explained, they have unpleasant smell. So they are called as aromatic compounds. So for example, you have toluene, phenol and naphthalene. What is the structure of toluene? See here. It is like a hexagon only and you have a methyl group CH3 above. One more is there, phenol group, hexagon only but a double bond over here and a hydroxyl group above. And this is a naphthalene ball, naphthalene structure, double hexagon. See here, you are having double bond in the alternate positions, and here you are having a double bond in this position and this position. So this is about naphthalene. So this is about your cyclic or closed chain, or you call it as ring chain compound. Types of isomerism. Already I explained you what is meant by isomer. Isomers means the compounds which are having the same molecular formula but different structural formula. Structure will be different, but they will be having same molecular formula. Actually, iso means same, meros means parts, and the phenomenon which is dealing with these type of compounds, you call it as isomerism. Okay, now let us see the types of isomerism. One is structural isomerism, and the other one you call it as stereoisomerism, or you call it as space isomerism or geometrical isomerism. Now, coming to the structural isomerism, you have subtypes: chain isomerism, position, functional, and metamerism. Now let us see what are the main causes for this isomerism. There are two main causes for the isomerism. First one is difference in the mode of linking. That means difference in the how they are being linked, in the type of link. For example, C4H10O. This is a single compound which has got a molecular formula C4H10O. It shows different types of linkages, and it stands for 3 different types of ether. Now let us see what are the 3 different types of ether. C4H10O, that means 4 carbon atoms and 10 hydrogen atoms, and they are linked up with 1 oxygen. So first one you have C2H5O, C2H5. Now count how many carbon atoms are there. 2 plus 2, 4. Okay. 5 plus 5, 10. Okay. So C4H10. In the middle, he brought O. How many times is ethyl is repeated? C2H5 means ethyl, no. C2H5 is ethyl. 2 means what? Di. So diethyl ether. With the same molecular formula, again, if that structure is different here, see. CH3O, C3H7. How many carbon atoms are there? Here 1 plus 3, 4. And hydrogen 3 plus 7, 10. O. So C4H10O. Here also C4H10O. But here CH3 means methyl. C3H7 is propyl. Because 3 carbon atoms means you call it as propane. And C3H7 alkyl group is propyl. Methyl propyl ether. Third type of ether is CH3O, CH3 twice. So CH3 means methyl. This one is isopropyl ether. C is 2 times. So 2C, that means 2 plus 1, 3. So here itself we are having 3 carbon atoms. And here 1 hydrogen, and here inside 3 2s are 6. 6 plus 1, 7. So this is propyl ether. Propyl means 3 carbon atoms. So methyl isopropyl ether. So these are the 3 types of ethers which are being linked up. This is only due to the difference in the mode of how they are linked up. Coming to the second cause, difference in the arrangement of the atoms or groups in space, how they have been arranged. So this type of isomerism is called as stereoisomerism. Let us see the example of 1,2-dichloroethane. So how we are going to have dichloro. Chloro means what? T. So 2. So C is double bonded with carbon. C is single bonded with hydrogen. C is single bonded with hydrogen. This C is single bonded with chlorine. C is single bonded with chlorine. So ethene means 2 carbon atoms will be there. C2H2. Okay. C2H2, so, and 2 chlorine atoms. So 1,2-dichloroethene. So you are having double bond of carbon, single bond with chlorine. How many chlorines are there? 1, 2. So dichloroethene. Next one. So the same thing, only thing, the positions of chlorines are changed and the positions of hydrogens are changed. C double bond C, chlorine here, chlorine there. Dichloro, 2 chlorines. Okay, so this is about dichloroethene. ethene. This is about the causes of isomerism. Different types of structural isomerism. I said no, 4 types of structural isomerism are there. The first type is chain isomerism. Already we have discussed about this. There are 2 or more compounds which are having similar molecular formula but have different arrangement of the carbon atoms. Either that arrangement may be in a straight chain structure or like a branched chain structure. For example, pentane. Pent means how many? 5. 5 carbon atoms. So C5H12. So how are they have been arranged in a straight line structure? See how many carbons are there? 1, 2, 3, 4, 5. How many hydrogens are there? 12. 3 plus 2, 5. 5 plus 2, 7 plus 2, 9. 9 plus 3, 12. So at the ends you have CH3, CH3. Methyl group is there. In the middle you are having CH2, CH2, CH2. So the carbon atoms are arranged like a straight chain structure. One more is a branched chain structure. So how many carbon atoms are there? 5 carbon atoms. 1, 2, 3, 4, 5. And how many hydrogens are there? 12, no? 3 plus 3, 6, 7, 8, 9. Plus 3, 12. So this is called as isopentane, or you call it as 2-methyl-butane. Because how many methyls are there? CH3 is 1 methyl, CH3 is 1 methyl. So you call it as isopentane or 2-methyl-butane. One more is there, CH3, CH3. So you are having carbon in the middle which is having single bonds with all the methyl groups. CH3 is methyl, CH3, CH3, CH3. This is called as neopentane. You call it as 2,2-dimethyl-propane. This is one pair, no? So this is dimethyl. This is also dimethyl, but it is recurring. 2,2-dimethyl-propane. Propane means 3 carbon atoms. 1, 2, 3. Okay, so 2,2-dimethyl-propane. 1, 2, 3, 4. 4 methyls are there. They are repeated 2 times. So you call it as 2,2-dimethyl-propane. The next type of isomerism is position isomerism. 2 or more compounds with the same molecular formula but differ in the position or substituent atom. Or you call it as functional group on the carbon atom. So 2 or more compounds, they are having the same molecular formula, but only difference is there in their position or substituent atom, or it may be a difference in the functional group on the carbon atom. Now let us see the functional group of alcohol. Alcohol means what happens at the end you will have OL, and how it is going to have the functional group OH. I have explained in the previous video. So propan 1-ol. So how many propan means how many carbons? 1, 2, 3. 3 propans are there. Ol means OH. So if you are coming from this side, always start from right to left. So OH, that means that functional group, alcohol group is present in the first position. So propan, 3 carbons, first position, alcohol, propan, 1-ol. This is belonging to alcohol functional group. Now let us see the position isomerism for the same second one. The same thing only, CH3, CHOH, CH3. Now here propan 1, 2, 3, 3 carbon atoms only, but there is a position in the functional group or OH. This alcohol has come to the second position. So you call it as propan 2. Second point, no, 2-ol. Here it is in the first position. So you call it as propan 1-ol. And here it is in the from here 1, 2 second position. So propan 2-ol. So this is about chain isomerism and position iso. The functional isomerism, the word itself has got functional isomerism, means 2 or more compounds with the same molecular formula but different functional groups. There will be a difference in the functional groups. For example, you are having CH3, CH2OH. You call it as ethanol. Here actually C2H5OH is ethanol. Only thing, the position of this particular functional group is here at the end, CH2OH. So here you are having CH3, CH2OH is ethanol, and one more functional isomer is CH3OCH3. This is dimethyl ether. Here what is happening, there is a difference in the functional group. Here the functional group is OH. Please see here, OH means hydroxyl group, that means alcohol group. Here the functional group is OH group, and here the functional group is ether group. You call it as dimethyl ether because CH3 is repeated 2 times. Dimethyl, methyl means CH3. CH3 is repeated 2 times. Dimethyl ether. Ether means ROR. R means alkyl group. I explained it already. Dimethyl ether. So this is belonging to ether group and this is belong to hydroxyl group. So this is ethanol and this is dimethyl ether. So this is functional isomerism. Now coming to the metamerism. This one, it arises due to the unequal distribution of the alkyl groups. That means alkyl groups will not be equal on both the sides, but they will be unequal on either side of the functional groups in the molecules. For example, you are having CH3O C3H7. So this is methyl group and this is propyl group. So you call it as methoxypropane, or you call it as methyl propyl ether. Ether means ROR. I gave no, ether group means ROR. Here CH3 and here C3H7. Here CH3 and here C3H7. This is methyl propyl ether, or you call it as methoxypropane. Coming to the second example. Now you are comparing these two. Here you are comparing these two alkyl groups. Now here C2H5O C2H5. Ethyl C2H5, it is repeated first time, second time, 2 times. So you call it as diethyl ether. ROR. C2H5 in the middle O. C2H5 in the middle O. So you call it as diethyl ether, or you call it as ethoxyethane. This is ethoxyethane. So this is about functional isomerism and metamerism.